Hello everyone, welcome to Vedantu Malayalam channel. I'm Sana Khan, your math master teacher, and today we are starting our first chapter of plus one. Oops, here plus two is written. My bad. Plus one, welcome to your very first class of very first chapter sets, where we are going to learn about introduction of sets and the different types of sets we have. All right. So how is plus one doing right now? Have your schools started? Have your studies started? And are you in the mood of studying finally or not? Like, we have reached end of June. July is almost going to start. So I guess that now we should get in a little study mode also. Agreed or not? Hi Truckers World, welcome. What's your name? So guys, basically, in the chapter of sets, you are going to learn about their representations, the different types of sets we have: empty set, finite set, infinite set, equal set, subset, superset, universal set. You learn their representation using Venn diagrams and the operations on sets, difference, complement, union, intersection, all of that. Now the question comes, ma'am, we are going to learn about all these things. But first of all, tell us what are sets and why are we learning about them, right? That's the most important question you should be asking. So yes, let's learn about sets. What are they? Why are they used in mathematics? And do they have any relationship with our real life also? Let's find out. Now, have you guys ever heard of the term sets? Let me know quickly in the comment section. Hi Kritishna, welcome. So in today's class, we are going to learn about these 5 topics: introduction of sets, representation of sets, the different types of sets we have, subset and superset, proper subset and proper superset. Okay, and in the lecture number 2, we will learn about Venn diagram and operations on sets on Tuesday. Okay. Yeah, I'm talking in English only. Acha, you want me to talk in Malayalam? I'm so sorry, that's not possible. I can converse in English with you and Hindi with you, but not Malayalam because I don't know Malayalam. So sorry for that. Okay, guys. So, yeah, welcome everybody. Welcome. Tell me quickly, what do you know about sets? Like, when you hear this word, what comes to your mind? Oh, English. In English, you have heard about sets, correct? And in real life, have you heard of set of something? Have you heard of jewelry set? Like you'll see on Myntra or on Amazon, a jewelry set. Yes, it is an organized group. Very good, Kritishna. Absolutely right. So basically, whenever we talk about set, we talk about multiple things, don't we? So sets are basically used to denote the multiple things together, or you can say a group of things, a collection of things. So what is set? It is a well-defined collection of objects. Now the objects can be anything. They can be capital letters, they can be numbers, they can be animals, they can be flowers, they can be colors, they can be anything. A group of anything is called a set. Alright, now how do you write a set? So sets are denoted with the help of capital letters. So every set will have a name like this: capital A, capital B, that is the name of the set. The elements of the sets, the elements means the objects which are inside the set are represented using small letters. Now, if I say that small a is an element of set capital A, then it basically denotes that this element belongs to the set. Okay? And if the element does not belong to the set, it is denoted as does not belong to. Okay? So, let's see some examples of sets. Electricity gone and now it's back. Okay. Yeah. So for example, let's see the example of a set. Suppose I write set A has prime numbers. What is set A having? Give me 1 second. Electricity fluctuating. Okay. Set A has prime numbers. Now, do you guys know prime numbers? 2, 3, 5, 7, 11, 13, and so on. So, it is a set of prime numbers. Similarly, I can have a set. Always remember the set is written inside curly brackets. Okay. So, I can have a set of colors. For example, black, blue, yellow. These are what? Set of colors, right? So, like this, we can represent any set and the objects inside it. Okay. Now, talking about the different type of representations of set, the different types of ways in which we can show a set, represent a set. Okay. First is roster form. Just now we have seen that if I want to display the elements of set by listing the elements inside curly bracket, then it is called roster form. For example, set A is a collection of cars. So let's say we have Creta, we have Swift Desire, and what else? What else? What else? We have Innova or some other car. So this is what? A collection of cars. So we write it inside curly bracket. This is curly bracket. So such a form is called as roster form. Clear? Let's see some examples. Now, suppose that set is defined as x such that, this symbol is called as such that x is an integer and x lies between -3 and -7. So, what will my set include in the roster forms? In the roster form, I will write it is basically integers between -3 and +7. What are the integers between -3 and +7? -2, -1, 0, 1, 2, 3, 4, 5 and 6. These are the integers between -3 and 7. We will not include -3 and 7, right? Similarly, set B contains x, where x is a natural number less than 6. Tell me natural numbers less than 6. 1, 2, 3, 4, 5. So simple. 6 will not be included because 6 is not less than 6, right? Next, set E, the set of all letters in the word trigonometry. So, trigonometry has how many letters? It has T, R, I, G, separated with a comma. Please remember, every element should be separated by a comma. Okay. O, N. Now, O and O are repeating. So, will I write it 2 times? Yes or no? Will I write it 2 times? No, I will not write it 2 times. I will write it single time only. Okay. Next is M, E, Y. Anything else? Anything that I left? Anything that I left? I guess no. So that is set E. Okay. Next is representation of set in set builder form. Now imagine that you have lots of elements inside a set. The set is very, very big. So will you denote all the elements 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and go on and on and on and on? How can you write so many elements? So when you have many elements, then it is better to just depict the relation among the elements. For example, set A has element x. What is x? You will write such that x is a prime number less than 7. Like this, I have a set. It is set builder form. Clear? Set B. Set B has element x. Who is x? Such that x is a natural number where x is greater than 2 and less than 20. Like this, I can represent a set. I want set of natural numbers which are greater than 2 but less than 20. This is set builder form. Clear? Let's see some examples. Write the following sets in set builder form. 3, 6, 9, 12. Can you tell me what is the relationship between them? Very simple. So we will say that let it be set A having element x such that x is a multiple of 3. X is a multiple of 3. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, right? So x is a multiple of 3 where x is basically greater than 2 but less than 13. Like this we can write, okay? Because multiples of 3 are so many. 15, 18, 21, all of them are multiples of 3. But we don't want to write them, right? Similarly here, very, very interesting. What is x here? Can you observe the pattern? The pattern is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, right? So set B has element x such that x is 2 to the power n, where n is basically greater than equal to 1, less than equal to 5, and n is a natural number. N is a natural number. Very good, Malvika. Absolutely right. The relationship is x is 2 to the power n. Alright. Clear to everybody? Okay. Now moving forward, just now I have written a term n belongs to capital N. But what is capital N? You should know that. There are some known symbols used to represent some known sets. For example, capital N is the set of natural numbers. Capital Z is integers. Capital Q is rational numbers. Capital R is real number. Z positive is positive integer. Q positive rational number. R positive real numbers. Okay. So you should know these names because they are basically used every now and then. Okay. Come on. Now this is a quick question for all of you. I am giving this question as homework. If you have understood everything till now about sets, then solve this question and let me know the answer in the comment section. Okay. Now let's learn about the different types of sets we have. Number 1, empty set, null set. From the name itself, can you tell me what is an empty set? Empty, which is empty, which has nothing. Simple, right? So suppose I define a set. Set A has element x such that x is a natural number where x is greater than 5 and x is less than 3. Now tell me a natural number which is greater than 5 but less than 3. Can you tell me quickly? Can anyone tell me a natural number which is greater than 5 and less than 3? Is it possible? Is it possible? No, it's not possible. So set A basically has nothing. It has nothing because no natural number is less than 3 and greater than 5, right? So it is a empty set, a null set. Okay. Now quickly tell me the answer of this question. Which of the following are examples of a null set? Set of odd natural numbers divisible by 2. Can you divide odd natural number by 2? Yes or no? Can you divide odd numbers by 2? No. 3. Can you divide it by 2? Nope. Right? So, odd natural numbers divisible by 2? Not possible. So, this is null set. Okay? Set of even prime number. Is there a prime number which is even? Prime numbers are 2, 3, 5, 7, 11, 13 and so on. Is there a prime number which is even? Yes. So, this set basically contains 2. It's not a null set. Next, x is a natural number where x is less than 5 and x is greater than 7. Is it possible? Less than 5, 1, 2, 3, 4. Greater than 7, 8, 9, 10, 11. Anything common? No. So, this is a null set. Next, y is a point common to any two parallel lines. Can two parallel lines have a common point? Can two parallel lines have a common point of intersection? No. So, this is again null set. So, A, C and D are null set examples. Clear? Next, singleton set. From the name itself, this set is very single. Okay. So, this set has only one element. So, for example, A is having only one color, black. My favorite color. So, it has only one color. It's a singleton set. Similarly, set B is basically X such that X is even prime number. How many even prime numbers are there? Only one, that is 2. So, it is a singleton set. Okay. Next, finite set. Again, from the name itself, you can say finite means countable. Countable. So, a set which is either empty or has a finite number of elements is called as finite set. For example, set A has 5 elements, 1, 2, 3, 4, 5. So, this is a finite set. Now, remember, every finite set will have cardinality of set. Cardinality basically denotes how many elements are there. So, cardinality of set A will be 5 because it has 5 elements. Okay. Next, infinite set, the number of elements cannot be estimated. For example, set A has all the natural numbers. X is a natural number. Now, can you count how many natural numbers are there? You cannot count. So, it will be 1, 2, 3, 4, dot, 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 dot. It will go on and on and on and on. So, it is infinite set. Okay. Let's find out which of the following sets are finite or infinite. Number 1. The set of months of a year. Quickly tell me, comment. Come on guys, comment and tell me. The set of month of a year, finite or infinite? Very good, Isha. Finite, we can count them. 12 months are there. Number 2, finite or infinite? Very good. Infinite. Why? Because dot 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 never ending. Right? Third one, finite or infinite? 1, 2, 3 and so on till 100. Absolutely right answer. Finite. We can count them. They are limited from 1 to 100. Next, set of positive integers greater than 100. Finite or infinite? Very good, Isha. Absolutely right. Infinite. Why infinite? greater than 100, 101, 102, 103, so on till infinity. This will be basically 101, 102 and so on, right? Set of prime numbers less than 99, of course, finite, because prime numbers start from 2. So they are finite only, na? Between 2 and bit 99. You can count how many prime numbers are there, right? Awesome. Next is equal sets. So if two sets have same elements, then they are called as equal sets. For example, let's say set A has x, where x is first 5 natural numbers. Okay, and set B has x such that x is a whole number greater than 0, less than 6. Are these two sets equal? Are they equal? Yes. Why? Because set A will have 1, 2, 3, 4, 5 and set B also has 1, 2, 3, 4, 5. So they have same elements. So they are equal sets. Similarly, you have equivalent set. If set A has, suppose 4 elements, 3, 4, 7, 9. Set B also has 4 elements, A, B, C, D. Now this has 4 elements. This also has 4 elements. So they will be called as equal sets? No, they are not equal. They are equivalent because they have same number of elements. Clear? They have same number of elements. Alright. Next is disjoint set. If two sets have no common elements, then they are called as disjoint sets. Isn't it very simple? What do we understand? Like no common elements means, again, set A has 3, 4, 7, 9. Set B has something like yellow, blue, pink. Are they having any element common? Any element common? No. So they are disjoint sets. They have nothing common. Okay. Quick question. Are the following pair of sets equal? Give reasons. Number 1. Set A has elements 2 and 3. Set B has elements solution of x square plus 5x plus 6 is equal to 0. Let's find out what is the solution of x square plus 5x plus 0. So x square plus 5x plus 6 is 0. X square plus 3x plus 2x plus 6 is equal to 0 because 3 2s are 6. X common, x plus 3. 2 common, x plus 3 is equal to 0. This implies that x plus 3 into x plus 2 is equal to 0. So x is equal to minus 3 and x is equal to minus 2. Isn't it? So it is having minus 2, minus 3. Are they equal? Tell me. So when we look at it, we feel, oh yes, they are equal. X plus 3, x plus 2. 3 and 2. That's what we need. But they are not equal because here they have clearly written 2 and 3. And the solution is minus 2 and minus 3. So are they equal? Not equal. The signs are absolutely different. Interesting question, right? There is a chance of mistake here. Number 2. A has a letter of the word follow. How many letters are there in the word follow? F, O, L, W. Okay. Set B has letter in the word wolf. W, O, L, F. Are they equal? Yes or no? Are they equal? Not equal? Well, check carefully. They are equal. Yes, equal. Why? Because W, W, O, O, L, L, F, F. Same elements, na? Order does not matter. Order will not matter. That W is coming first, L is coming later. Order does not matter at all. You can write any element first, any element later. So they are equal sets. Okay, great. Now coming to a very important topic. What do we understand by subset and superset? Now, if we have two sets A and B such that every element of A is also an element of B. For example, set A has elements 1, 2, 3. Set B has element 1, 2, 3, 4, 5 like this. 1 is here, 2 is also here, 3 is also here. So every element of A is also an element of B. Then we say that A is a subset of B and B is a superset of A. So simply the relationship becomes what? The relationship becomes A is the subset, B is the superset. It's like father and son relationship. Okay. Similarly, proper subset and proper superset. See, when we are defining subset and superset, A can be equal to B. Can be equal to B. Okay. But if we have clearly mentioned that A cannot be equal to B and every element of A is there in B, then we can clearly say that A is a subset of B and B is a superset of A. But we call them as proper subset and proper superset. Alright. Next is universal set. It is like father of all, father of nation. Okay. A set which has elements of all the related sets without any repetition of elements. So suppose that I have a set A which has 1, 2, 3. I have a set B which has 3, 4, 5. And I have a universal set which has 1, 2, 3, 4, 5. So every element of A is there in universal set. Every element of B is also there in universal set. So this set is called as universal set, which has everything inside it. Everything of all the related sets. Okay. Alright, here are some important symbols that you guys need to know which can come up in some questions. U means universal set. This symbol is basically belongs to. It says that B is an element of set A. This symbol means does not belong to, not an element of B. This symbol means null set or empty set. U symbol means union. Like inverse of U is intersection. This is subset. This is superset. We know already. Okay. Now let's solve some questions quickly. Comment the answers below. Examine whether the following statements are true or false. Elements AB is not a subset of ABC. Set AB is not a subset of ABC. True or false? Any guesses? False. Yes, it is a subset. Very good, Malvika and Isha. It is a subset of ABC na, because AB, it is present. So subset only na. Okay. AE is a subset where X is a vowel in English alphabet. A set having AE is a subset. Yes, correct, true, because A and E are vowels only. Next, 1, 2, 3 is a subset of 1, 3, 5. 1, 2, 3 is a subset of 1, 3, 5. False. Because 5, 2, they are not same. Next, A is a subset of ABC. A is a subset of ABC. True, absolutely true. Lastly, X is an even natural number less than 6. It is a subset of X is a natural number which divides 36. Now this is interesting. Let me write down here. Statement E is saying that X is a natural number less than 6. 1, 2, 3, 4, 5. It is a subset of X is a natural number which divides 36. Who can divide 36? 1, 2, 3, 4 and 6 and 9, then 12, then 18 and 36. So now you tell me true or false. X is an even. Oh, my bad. I'm so sorry. I'm so sorry. This is not there. They are saying even natural numbers. Okay. Even natural numbers. So only 2 and 4 will be there. Right? Only 2 and 4 will be there because they are saying that even natural number less than 6. Absolutely right. This is a true statement. Very good, Isha and Malika. Absolutely right. Alright, next question. Write down all the subsets of the following set. Now, here is a very, very important question. Important. Why? Note down. Every set has two sure subsets. What are the two sure subsets? One is phi, that is empty set, and other is set itself. Okay. So what are the subsets of this set? Null set and the set itself are subsets of a given set. Okay. Similarly, for AB, it will be null set, set of A, set of B, and set of AB. These are the subsets. For 1, 2, 3, it will be null set 1, 2, 3, then 1, 2, 1, 3. Similarly, 2, 3. And lastly, 1, 2, 3. All of them are subsets. Okay. Set having 1, set having 2, set having 3. Set having 1, 2, 1, 3, 2, 3 and 1, 2, 3. All of them are subsets. Clear? Similarly, null set, what will be the subset? Phi. Null set, subset is null set. Nothing. Okay. Alright, let's practice some more questions quickly. If you have understood everything till now, tell me the answer. Given two sets, set A 1, 3, 5, set B 2, 4, 6, set C 0, 2, 4, 6, 8. Which of the following may be considered as universal set for A, B and C? Tell me. Option A, option B, option C, option D. Which is universal set? Universal set means it should have all the elements of A, all the elements of B, all the elements of C. Isha is saying option C. Let's check. Option A, 8. 8 is not there. Not possible. Null set? Obviously not possible. What about option C? It is having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is the universal set of ABC. But what about option D? What about option D? Can it not be the universal set? It has 0, 1, 2, 3, 4, 5, 6, 7, 8. Yes, this can also be universal set. Okay. Both of them are correct. Option C and option D. Both of them are possible. Clear? Okay. Oh my god, this is also messed up. Give me a minute. Why this happened? Okay, fine now. Match the following on the left and on the right. This is roster form. This is set builder form. Tell me for first one, what is the right answer? Set having 1, 2, 3, 6. Which set? X is a prime number and divisor of 6. X is an odd natural number less than 10. X is a natural number and a divisor of 6. X is a letter of the word mathematics. Very good, Isha. Option C is the right answer. 1, 2, 3, 6 are natural numbers and divisor of 6. Right? Second, 2 and 3. What about 2 and 3? Prime number and divisor of 6? Absolutely right. 2 and 3 are prime numbers and divisor of 6. Option 3. MA. Now this is the very simple, obviously. This is option D. Letters of the word mathematics. And lastly, we have 1, 3, 5, 7, 9. What are they? 1, 3, 5, 7, 9. They are option B. What are they? They are odd natural numbers less than 10. Clear to everybody? Understood? Great. Next question. State whether each of the following set is finite or infinite. Quickly tell me the answer. Set of lines which are parallel to x-axis. How many lines are parallel to x-axis? Finite or infinite? Finite or infinite? Parallel line to a given lines are always infinite. There can be so many lines parallel. Okay. Very good. Next, set of letters in the English alphabet. Finite or infinite? Set of letters in the English alphabet. How many letters are there in English alphabet? Finite, na? 26 letters. A, B, C, D till Z. 26 letters. So, finite. Third one. The set of numbers which are multiples of 5. Multiples of 5. Infinite. Factors. Remember, factors are always finite. Multiples are always infinite. Okay. Lastly, set of animals living on the earth. Now this is a very confusing statement. I don't know whether to call it finite or infinite because the animals living on earth are uncountable, we will say infinite. Why we will say infinite? Because we can't count them. If you count them, next day some more animals will be born. It's difficult to tell. Some are even undiscovered. So let's call them as infinite. Okay. All right, guys, that's all for today. So we have completed about what are sets and the different types of sets that we have. So what did we learn today? A set is a collection of well-defined objects. There are some different types of set. Null set having no element. Finite set having a given number of elements. Infinite set, we can't count them. And equal sets which have same elements. Next, singleton set which has only one element. Power set which is like having all the elements. Subset where elements of this set belongs to the other set, then it is called subset. And universal set, a set which has everything. Alright. So guys, if you want notes of the lecture, quickly join our Telegram channel. I will share the notes right now there itself. And if you are new on the channel, quickly subscribe to Vedantu Malayalam. We will have super interesting, super fun lectures every day for mathematics, physics, chemistry and biology. For your +1 preparation, every day we'll enjoy and have class just like this. It was really wonderful class. Very active participation by all of you. So thank you so much for joining. If you enjoyed today, do hit the like button, share this video with your friends, and we'll have lots of fun together every day. Alright, thank you everyone for watching. Do leave a comment and share your feedback that how did you enjoy today's lecture. Alright, bye Isha, bye Malvika, bye dear students. Thank you so much for joining. Have a good day, have a good night. Bye bye, bye guys.